Hello everyone. In this video, I'm going to talk about scientific notation. Scientific notation is a convenient way to express a very small or a very large number. So for example, if we have a number like this, and if you try to put it on your calculator, so normal calculator has only, so it can display only certain number of digits. This would not be able to put into a normal calculator. So we can put this number into scientific notation. Scientific notation have this form p times 10 raised to power k. So it's a shorthand to write the very small or very large numbers. So what are the restrictions on p? What is p? So p can be any digit between 1 to 9. So P can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So any single digit. And the form of scientific notation is, so we write the very first non-zero digit, the non-zero digit in the first place, and then we put the decimal sign, and then we write the rest of the number. And depending on where we put the decimal sign, so we write 10 raised to power k, where k is the power. So it can be positive or negative power. So in order to write the scientific notation, there are a few things. The sign of the number does not change. Move the decimal place to the first non-zero digit, and then write the rest of the digits as it is, times 10 raised to power k. And that power of 10 is determined whether you're moving, how many places you're moving the decimal points to the left or to the right. So it is positive if you move it to the left. It is negative if you move it to the right. So I'll do few problems soon. Before that, let's take a look. What are the rules for powers of 10? So when we multiply two powers of 10, we add the exponent. So if we just look at this one, 10 raised to the power 5 times 10 raised to the power 6. So this means we have 5 copies of 10, and if we look at the second one, so this means we have 6 copies of 10. So if I don't know the rules of exponents, so how would I do it? So total we have 5 plus 6. So now finally we have 11 copies of 10. So basically we have the power 5 here, we have the power 6, and we have the power 11. So we just simply added the exponents and we got 10 raised to power 11. Thus we have this rule that if you have the same basis and there is multiplication in between, so we add the exponents. So in this case, we simply did 10 raised to power 5 plus 6, that is 10 raised to power 11. Okay, let's try next one. So in this one, 10 raised to power negative 9 times 10 raised to power 2. So again, since there is multiplication in between, we add the powers. So negative 9 plus 2. So we got 10 raised to power negative 7. And if you want to write this in terms of positive exponents, so you can write this as 1 over 10 raised to power 7. So whenever the power goes from top to bottom or bottom to top, it always switches the sign. All right, so we learned that when we multiply the powers of 10, add the exponents. Similarly, when we divide two powers of 10, we subtract the exponents on the denominator. So in this case, 10 raised to power 5 over 10 raised to power negative 2. So 5 minus, so subtract the power on the denominator. So the power in the denominator is negative 2. And we know that when we multiply negative with a negative, we get positive. So that is 10 raised to power 7. So where are we going to use these rules? Let's say we have to solve this problem. So 3.14 times 10 raised to power 5 divided by 2.0 times 10 raised to power negative 2. So we can separate our 3.14 divided by 2.0, and then you can deal with your powers of 10. So 5 minus 2, so that's the power 7. So you can just simply do 3 divide 3.14 by 2 on your calculator, and you can get your final answer in scientific form. All right, so let's do some problems where we convert the number into scientific form. So first one is express the following in scientific notation. So in this one, so let's deal with the number 341.5. So scientific notation means after first non-zero digit, you put the decimal sign and write the rest of the digits as it is. Okay, so now we need to also write 10 raised to power some number, and 10 raised to power 5 we already have here. So what should be the power here? If you notice how we move the decimal 1, 2, 2 places to the left, right? So now this number is smaller, so it means the power should be positive. So when you move 2 places to the left, you use the positive power. So this should be 10 raised to power 2. And we learned that when we have the multiplication, so exponents are added. So we got 3.415 times 10 raised to power 7. So that is our correct answer. In the next problems, we're going to do some practice with, we're going to figure out the number of sig figs, precision, and the scientific notation for these numbers. If you don't remember, so let's just recall our um, number of sig figs rule. So first is all non-zero numbers are significant, and also we learned in the lecture that if you have trailing zeros before the decimal, that are not significant. All the trailing zeros after decimal, they are significant, and the leading zeros are not significant. All right, so in this problem we need to figure out for each number, we need to figure out the accuracy. That means the number of sig figs. We need to find the precision. So precision means we are figuring out the place value of rightmost sig fig. And then we need to write in the scientific notation. 4.125. So if you want to figure out the number of sig figs, so all digits are non-zero, so number of sig figs or the accuracy is 4. So what is the precision? So precision in this case is the place value of the rightmost. So rightmost is 5. So the place value is, so this is at 1000th place. So we write 1000th place. So that's the precision. For scientific notation, we have already decimal after one non-zero digit, and we can just write 10 raised to power 0. So 10 raised to power 0 is always 1. Just remember that. Any non-zero number raised to power 0 is always 1. Alright, so in the next one, 0.00768. So how many number of sig figs? So in this case, the leading zeros or trailing zeros before the decimal are not sig figs. So these are not significant. So it means the number of sig figs is only 3. And if we talk about the precision, so what is the place value of 8? So 10th, 1000, 10,000, 100,000. So in this case, we have 100,000 place value. So precision 100, thousandth. And for the scientific notation, so we can write this as 7.68, and then we need to decide on the power. So we move the decimal 1, 2, 3 places to the right. So it means we need to put -3. So we move the decimal to 3 places to the right. Next we have 0.20. So in this case, so trailing zeros after decimal, they are significant. So these are significant. So the sig figs are 2. So we have 2 sig figs. And the precision is 100th place. And the scientific notation would be you move the decimal 1 place to the left. So it would be 2.0 times 10 raised to power -1. In 2.000, so all the trailing zeros are significant because they're after the decimal. So number of sig figs is 4. So these zeros are significant because they're after the decimal. Precision is tenth, hundred, thousand, thousandth place. So thousandth place. And the scientific notation would be 2.000. So 10 raised to power. We didn't move anything. We didn't move the decimal place. So 10 raised to power 0. In 2050, so we know that trailing zeros before the decimal. So if there is no decimal, we think that the decimal is in the end of the number. So this is a trailing zero before the decimal. So this zero is not significant. So number of sig figs is only 3. And the precision is the rightmost sig fig, which is 5 here. So precision is 10. And if you want to write in the scientific notation, so we always write the decimal after the first non-zero number, 2.05, and we only write the sig figs. So 2.05 times 10 raised to power. So how many places did they move? So decimal is moved 1, 2, 3 places to the left. So it should be 10 raised to power 3. Next we have 2050.0. So all the trailing zeros are significant after the decimal. So 1, 2, 3, 4, 5. So in this case, the number of sig figs is 5. And the precision is 10th. And if we want to write in terms of sig figs, so 2.0500, and decimal is moved 3 places to the left. Next we have 0.8735. In this case we have 4 sig figs and the precision is 10 thousandths place. And the sig, if you want to write in the scientific notation, so you need to move decimal 1 place to the right. So it will be 8.735, and 1 place to the right, it means 10 raised to power -1. Next we have 3850. Again, the last zero is not significant. Number of sig figs is only 3. And the precision is tens place. And the scientific notation, so you put a decimal after 3 and only write the sig figs. So we have 1, 2, 3. So when there is no decimal here, so you assume that it's in the end, so you start counting how many places the decimal is shifted. So in this case, it is 3 to the left, so positive 3 on the top. So basically 3.85 is less than 3850. So whenever you have this number smaller, so you always have positive power. Next we have 3850 and you have a bar on the top. So this bar on the top tells us that this zero is significant. If there is no bar, the trailing zero is not significant. So in this case, the number of sig figs is 4 and the precision will be ones place or the units place, and the scientific notation would be, so you write all, so you put the decimal, write all the sig figs, and we moved 1 2 3 places to the left, 10 raised to power 3. Last one, again the trailing zeros are not significant, so these are not significant, so number of sig figs is only 3. Accuracy is this one, thousands place, and the scientific notation would be, so you put the decimal after first non-zero digit, write all the significant figures and see how many places the decimal is moved. 1 2 3 4 5. So we have 10 raised to power 5. So this is how we figure out the accuracy, precision, and also we convert into scientific notation. Let's do one more problem. We need to calculate this and we need to express our answer in scientific notation. So if you want to use your calculator for the 10 raised to powers, so for that we can use exponential button. So that does 10 raised to power x. So this is a key on calculator. And I'm talking about Sharp EL20 520x calculator. So it has this exponential key that you can use to figure out 10 raised to some power. All right, so let's do this problem. In this one, we have so many powers of 10. So what I'm gonna do is I'm gonna separate out all the other numbers. So 4.67 times 4.59 times 3.85 on the top, and we have 1.27 times 2.89 on the bottom. And for the powers of tens, I'm gonna use my rules. So all the powers of tens which are multiplied, let's write them together. And then we have some in the denominator. Okay, so use the calculator to figure out this part. And when we use the calculator, we find that we have 22.484785. And what is a 10 raised to power, right? So all the exponents are added together if they are separated by multiplication. So in this case, I'm gonna add all the exponents on the top and all the exponents on the bottom. So we get 22.484785 times, so negative 4 and negative 8 is negative 12. So negative 12 and plus 6. So that is negative 6. And in the denominator, we have 3 plus 5, that is 3 plus 2, that is 5. So we get, and now we know other result, that if the powers of 10 are separated by division, then the power that is in the denominator, that gets subtracted. So minus, that gets subtracted, so minus 5. So ultimately we get 22.484785 times 10 raised to power negative 11. And it's saying that we need to express our answer in the scientific notation. First, let's convert this into scientific notation. So in this case, move the decimal one place to the left. So we're going to write this as 2.24844785 times, so 10 raised to power, since we move to the left, 10 raised to power 1 times 10 raised to power negative 11 that we already have. So negative 11 plus 1 ultimately is going to become negative 10. And in the end, we only give our answer in three sig figs because in the original problem, all the numbers are given in three sig figs. So that is our answer. So 2.25 times 10 raised to power negative 10. So 3 sig figs for the answer. I hope that makes sense. So make sure you also do your lab problems, and I'll see you in the next class. Bye for now.